Imagine a world that never heard a gunshot. No rifles, no pistols, nothing but swords and spears. Deep inside ancient China, Taoist alchemists worked quietly, searching for something they believed could grant eternal life.
They were not hunting for weapons. They wanted the legendary elixir of immortality, a cure for death.
Sulfur, charcoal, and potassium nitrate were blended together, an ordinary mixture about to become something extraordinary.
When heat touched that mixture, it ignited violently, and history quietly shifted in one blinding moment.
That accidental blend became gunpowder, the world's first true explosive, born from a search for immortality. Potassium nitrate supplied oxygen. Charcoal became fuel. Sulfur sped up the burn inside sealed spaces. At first, no one thought of weapons. Gunpowder lit up fireworks, ceremonies, and sacred festivals instead. Loud explosions terrified enemy soldiers, long before a single bullet had ever been fired at anyone.
Engineers noticed something powerful. If gas could throw flame outward, it could also throw solid objects.
Soldiers strapped bamboo tubes filled with gunpowder onto spears, creating a strange new weapon called fire lance. When lit, it blasted flame, smoke, and sharp fragments toward anyone standing bravely in its path.
It was not a true gun yet, but it introduced the principle every firearm still follows today. Expanding gas pushing a projectile through a narrow barrel, that single idea would shape centuries of warfare. Humanity did not invent the gun overnight, and it took centuries of failure, trial, and battlefield necessity. Bamboo barrels kept cracking under pressure, and they simply could not survive repeated violent explosions for long. Chinese craftsmen turned to bronze and cast iron, forging the very first true hand cannons. By the 13th century, stronger metal barrels allowed heavier projectiles to travel farther with far greater force. Without modern physics, these craftsmen were quietly discovering the very foundations of internal ballistics through experience. That fragile Chinese invention soon traveled west along trade routes, ready to reshape the entire world. Early guns were loud and unpredictable, often more dangerous to the shooter than to the enemy. When gunpowder reached Europe, blacksmiths and military engineers instantly recognized its enormous and terrifying potential. Constant warfare across Europe meant every small advantage could decide the outcome of an entire battle. Stronger forged iron and cast bronze barrels handled higher pressure, sending projectiles farther and faster than before. In the 15th century, the matchlock arrived, using a mechanical trigger to lower a burning cord. For the first time, soldiers could actually aim before firing, changing accuracy and confidence completely forever. But a glowing fuse failed in rain and wind. Soldiers needed something faster, safer, and far more dependable. By the early 16th century, the wheel lock used a spinning steel wheel striking iron pyrite for sparks. It worked much like a modern lighter, but each mechanism demanded expensive, handcrafted precision engineering. In the 17th century, the flintlock arrived, striking flint against hardened steel to spark ignition instantly. It was simpler, cheaper, and remarkably reliable, dominating battlefields across Europe for nearly 2 centuries straight. Flintlock muskets played a decisive role during the American Revolutionary War, shaping the birth of a nation. Coordinated volleys during the Napoleonic Wars proved that discipline and firepower together could reshape entire empires. Governments began building centralized armories, producing standardized ammunition with far greater consistency and reliable quality. Interchangeable parts became a manufacturing philosophy that would soon influence sewing machines and early automobiles too.
Firearm manufacturing techniques quietly spread into civilian industries, helping ignite the massive industrial revolution itself.
Engineers realized consistency mattered as much as invention, since every copy needed identical, dependable performance. That relentless pursuit of quality control still shapes modern engineering standards across countless global industries. By the early 1800s, firearms had transformed from handcrafted tools into true industrial machines. But the greatest transformation was still ahead. Cartridges, smokeless powder, and mass production were coming next.
What if the most important invention was not the gun, but a tiny piece of metal?
The Industrial Revolution replaced skilled craftsmen with factories, producing standardized parts using powerful precision machine tools. Parts made in different factories now fit together perfectly, making repair and production dramatically faster overall.
The self-contained metallic cartridge combined powder, bullet, and primer into one single sealed unit.
Reloading became faster, moisture resistance improved, and dangerous accidental powder spills were finally eliminated completely. Inventors soon created repeating rifles and lever action systems, drastically reducing time between each shot. Bolt action and semi-automatic designs followed, each one focused on speed, reliability, and mechanical efficiency.
Stronger steel alloys allowed higher chamber pressures, improving safety, durability, and long-term firearm performance.
But the greatest breakthrough was never firing faster. It was learning to fire far smarter.
Modern engineers now use computer-aided design, building detailed digital models before any prototype exists.
Finite element analysis simulates firing stress, helping designers find weaknesses long before real testing begins. Advanced CNC machining now manufactures components with microscopic precision across thousands of identical units every day. Modern materials like aerospace aluminum and advanced polymers reduce weight while improving strength and corrosion resistance. Smokeless powder now generates far more energy while producing less smoke, residue, and unwanted fouling. Modern optics, red dot sights, and thermal imaging have completely transformed hunting, sport, and defense. Safety has become essential, with drop safeties and trigger blocks preventing dangerous accidental discharge entirely.
Artificial intelligence and smart sensors are already reshaping military research and modern defense systems worldwide.
Concepts like biometric authentication and predictive maintenance are quietly entering advanced modern weapons systems around the world. Ethical questions around autonomous weapons and global regulation are now central to serious worldwide debate. From an accidental discovery to artificial intelligence, one question remains: achievement or lasting human responsibility?